Hi, friends, welcome back. After looking into the details about the first stage of operational amplifier, that is the differential amplifier, and its wonderful property called the virtual short. Now it is time to see how this virtual short is going to make wonders. So, what is virtual short? The differential amplifier, as we discussed in our previous session, if one of the inputs is not connected directly to the input source, then it will follow the other input if it is connected to the voltage source. So one of the inputs is connected to voltage source, and if other one is not connected to voltage source, instead if it is connected to some passive network, then the input which is connected to passive network will follow the other input which is directly connected to a source, which means that the voltage between the two inputs is always equal to zero. And if you look at the connectivity between the two inputs, then in each direction one of the two transistor emitter base junction gets reverse biased. In one direction, the Q2 from negative to positive, if you look at it, then Q2 base emitter junction is reverse biased. If you look for positive to negative direction, then base emitter junction of Q1 gets reverse biased. So whatever be the case, it is sure that no current will flow between the two input terminals. Since the voltage is always zero, so it looks like a short circuit. But the problem is, if the two points are shorted in any electrical system, then there should be current flowing. And but this is a special case where there is no current flowing, and hence we called it virtual short. Now let us see how this virtual short will help us in working and creating more wonders. How this virtual short will make our circuit an operational amplifier, that means an amplifier that can perform some basic operations, mathematical operations like addition, subtraction, multiplication, division, integration, differentiation, and so on. How it can be done? So let's begin with a simple one amplifier circuit. It is called an inverting amplifier. So we have connected the non-inverting input to the ground, and to the inverting input we connect our input via a resistor. So we have input here, we have output here. This is our resistor 1, this is our resistor 2. So that's inverting terminal. Okay, now what is the difference? The difference is the non-inverting input is directly connected to the voltage source of zero potential, whereas inverting terminal is not connected directly to any source, but yes, it is connected to source, but through some resistive network, not directly as we have connected here. So that makes the difference. So what does it say? The input which is not directly driven by any source has to follow the other input which has direct driving source. So that means if this point is at zero voltage, then this voltage between these two should be zero, which means the voltage at this point is also 0 volt. So let me call this point P. So since inverting input 0 volt, therefore voltage at P is 0 volt. So this voltage is 0. Okay, what's fun in that? So as of now, nothing funny. Next, the fun begins now. Because this is 0 volt, this is some voltage Vi applied, then there will be some current flowing I, and the current I flowing will be equal to Vi minus Vp divided by R1, which means Vi minus 0 by R1, that means Vi by R1. That's a current flowing through resistor R1. Where should this current go? It cannot go into this because no current can enter into the operational amplifier because the current between these 2 points is always 0. Therefore, no current can go into this. Then the only option is this whole current has to flow through R2 and reach the output. The same I has to flow through R2 and reach V0. Now, what is the voltage difference between these two? So the voltage difference between these two is 0 minus VO. So the same current I is flowing, and that is 0 minus VO by R2. So voltage across R2 is 0 minus VO by R2. That means minus VO by R2. So this is also I, this is also I. Therefore, we can say that minus VO by R2 is equal to VI by R1. Therefore, we can say VO is equal to minus R2 by R1 times VI. Done. That's so simple. So whatever amplification you want, just you decide what should be R2, what should be R1, and this ratio will decide what will be the voltage gain of this circuit. And because the input is applied to inverting terminal, yes, definitely the output is going to be a negation of the input and given by this ratio. Okay, what is so fun of that? Yeah, let me try the same circuit without this operational amplifier. So this I called Vi, this I called R1, this I called R2, this I called V0. Done? Okay, done. Then what else? Then because of the operational amplifier, we have been seeing that this point voltage is 0. So that means it is equivalent to connecting this point to ground. It is equivalent to connecting this point to ground, and if you connect this point to ground, what would happen is this I current I whatever we have found here will just sink into the ground. Then what should come here? Nothing. There is no further flow of this current as we thought here. So this current I will not be flowing through R2, and hence there won't be any connection between I and V0. And if there is no connection between I and V0, and definitely there won't be any connection between Vi and V0. As we have seen here, the I is the connecting link between the input and output. At the input side, if you look, it is Vi by R1 is the current, and the same current is made to flow here because of that special property of operational amplifier called the virtual short. This point voltage becomes 0, and hence I will flow, which is given by this much. And because there is no current flowing into this, therefore This is not possible here, and hence this current has flown into R2, gone to V naught, and therefore we could write this expression, and same currents were flowing, therefore we could equate them, and then we got this as our simple expression. So now you can realize how simple the amplification could be if you use a operational amplifier. The only reason is the virtual short. So that's the one example I could start with to say how virtual short of the differential amplifier is going to create wonders and make our lives easier. If we wanted this amplification using our transistor circuit, then we would have to do lot of circuits to design that, talk about all circuit components, biasing and all that. Here in nothing to talk about that. Everything is taken internally by the operational amplifier. Only you need to worry about what should be R1, R2 values, and that is going to decide what will be the gain, and that will decide what will be the output. So that makes our life so simple, isn't it? Yeah, sure. So many more such applications to follow in our coming sessions. So please keep watching. So till the next session, take care. See you. Bye.